Thank you very much for your attention.
Thank you, Ravi. At this time, we're going to jump into some questions we received during registration and a couple from during the presentation. Our first question is, which minerals can this be used for? Does it work in low light situations, and how accurate is it?
Yes, so from the minerals perspective, it doesn't matter, any type of minerals. It is an RGB sensor, so it's not. There is no other types of chemistry or the spectral signatures are built in. So you will see what's the gradation in terms of the size gradation, and it can be applied to any type of minerals, either metal side, coal, cement, aggregates. And I think there was a follow-up question there, Haley.
Does it work in low light situations, and how
Yes.
accurate is it?
Yep. So yes, it can. The lighting is definitely an important factor for the installation, where if it's a very indoor environment or a dark environment, the lighting is needed. There are various great setup for the lights. The LED lighting is very helpful. And the consistent lighting is good, which means sometimes if you're installing an outdoor environment, that's always it's a tricky part, because when you have a sun glare, when you have sunrise, that can play a bit more, curveball here about the detection. But we have trained our model to overcome those situations. But still, the lighting is definitely helpful, as we have seen in our experience. And the accuracy side, I'll be happy to share more on that, more examples, but we have seen the detection is very accurate based on the sieve size sampling that has been done, in a physical sieve size sampling, and it's been compared with that method.
Great. Where do you see AI going in mining in the next 12 months and in the next 24 months?
Yeah, another great question. We see that AI is changing a lot of things, the way we operate now in terms of the mining and the coring side. We see huge applications in how the blast design can be improved. So that's a very practical applications. And when we are seeing a lot more now on the plant side, predictive maintenance side, we've seen huge improvements on the autonomous, making the systems autonomous. So that's where the AI is applied. But where I see in the future, in the next 2 or 3 years, a lot more on the autonomy side, which means making the machines autonomous to really understand, making the machines perceive things. The failure breakdown, usually happens. So those are the areas where I see a lot of different applications of AI, including the workforce training. And if we can generate more knowledge-based, generative AI models are there that can be applied to really train the newer generation of workforce that's coming now, to train them very easily with the generative AI models, of having a huge understanding of, let's say, a company which has almost several hundred thousands of blasts are there. And sometimes those knowledges are acquired by several years of experience. You have worked in the field for 50 years. But what if we have those blast data being applied into a generative AI model and build a knowledge base, from that, for someone who is coming into the workforce and really understand quickly to what last 50 years of knowledge can be distilled, properly. So that's where I see a training side where the generative AI models can be utilized now.
Great, thank you. How does the camera work?
So the camera works. It's a stereoscopic system, which is a dual lens. It triangulates. It captures, the images, triangulates, which builds the depth information. depth information builds the measurements, and that's what you derive the different particle size gradation, any type of colors and texture information, from that. So the sensing, optical sensing happens, and we take that data to build more applications and algorithms on top of that.
Awesome. In iron ore business, crusher is playing a vital role in producing the desired saleable material. Is there any automation process for monitoring the infeed of the crusher so that the optimum fragmentation size can be fixed?
Yeah, great point. And the question here is really towards like, how do we understand the feed side, feed rate that's coming up, and how to optimize it in real time. So now we have the data that's coming, which is really real time. So if that can be integrated with the plant control systems, you can build this, adjustment real time then. What that means is you build these recipes of if this happens, do this. And that can be done through the plant control systems. If I'm seeing a size of, if your agreed size is 40-inch, but it is the plan as the camera is detecting, and it's about 48-inch. So instantly detects, the alert can be sent in the plant controls, and this plant control systems alerts are more real time, which means as it's seen. And now if you have another trigger in the plant control to adjust this, the feed rate, which means either stop the crusher and make the secondary breaker active instantly, or just stop the crusher altogether. So all this can be built in the plant control systems to put these alerts in there.
Great. How does it handle the dusty environment?
Yes, so the dust, the camera itself, the lens is a polarized lens, which means it can remove any type of, dust, visible dust layers and everything. But if it's a very, a dust which a human eye cannot see as well, that's where we don't have an option of self-cleaning in this system. In that case, we have an alerting system where we alert the operator on the side or someone on the side. They go and they can clean the camera then.
Awesome. Are there API integrations?
Yes. The system offers, the full APIs that can be integrated to any third-party applications or your database. It's a fairly simple, process of just hooking up and with a webhook, and it moves the data.
Great. How small of material can you monitor on a belt application?
Yeah, so that's a pretty good, precise question here, because sometimes if you say how small it can monitor, it depends upon where it's installed. So now in the belt, what we have seen in our experience, it can monitor up to 2 to 4 millimeter very easily. And install at a height of, 4 meter, 4 to 5 meter. But if you lower it to, to a 2 millimeter, even it can go even lower in the size of the detection as well.
How do you take into account blending between different patterns?
Yeah, so the blending between different, patterns here that's where I see a lot of really powerful information can be gleaned on. Which means if you are shooting 30% info and the blend, a blended product, or if you're just shooting other types of product there, and if you run through the crusher, you will see that, right? How exactly the crusher performed. So now I have something to play, and if you are able to, because now you have each shot, you may be putting one shot here, another shot here, and you have shot with a different pattern, or into different explosives itself, you will see that what the load performed. So we can draw that differentiation of what that load was there to see each pattern understanding, from there. So this separation can happen because it's based on the timestamp and the different equipment IDs which are bringing those material, to the crusher. So those information can be very, very impactful of how you make the blasting optimization decisions.
Awesome. I'm curious, how can your vision system determine or grade as indicated in one of the presentation slides?
Yes. So, well, I should clarify that it's a size grade. We don't determine chemistry at the moment. It's all based on the right now the texture, so it can determine the colors and the contamination, and then the size. The chemistry of the rock is not determined through the sensors. For that, there are other advanced sensors are there, as I mentioned, the hyperspectral side.
And we will take one more final question, which is the color coding based on wavelength absorption of the rock or fluorescence imaging?
So the colors right now is just based on training the rock data, which means we can see the texture information, and that's how we are looking at each kind of pixel information and building that kind of color information there. We are not using any type of wavelength information because again that's more on the spectral side, and that's related to the chemistry side. Our detection for the colors are entirely based on the pixel information.
Okay, excellent. Thanks, Ravi, for a great presentation today. Now we will wrap up the live event. Thank you all for attending the Using 3D Machine Vision, AI, and Edge Computing to Optimize Mine-to-Mill Performance, brought to you by Pit and Quarry Magazine and our sponsor of the event, Strayos. A recording of this webinar and other upcoming webinars from Pit and Quarry will be posted to pitandquarry.com/webinars. Thank you all for attending, and we hope you will join us again soon for another great webinar.
Thank you.